Well, good morning, good afternoon, good evening, whenever you are watching this. I'm going to go through two more examples. One of them is number 9 from worksheet A. Worksheet A is the worksheet that you got on Friday. We are going to graph this one in radians because we see pi over 4. So the first issue is sine. So sine parent graph in radians. (360 degrees), 2 pi radians. 180 pi, 90 pi over 2, 270, 3 pi over 2. So there's the parent graph for sine in radians. Amplitude, remember, is always positive. Amplitude is that number there, 10. I'm going to deal with the amplitude and the negative sign first. So this goes up to 1 and down to -1. This is not going to be to scale because I made one unit too big. But the negative sign reflects it over the x-axis. And then the 10 is really a vertical stretch. So it takes all your y values and multiplies them by 10. So it reflects it over the x-axis. So this is what it is after the reflection. Now vertically stretch it by 10. So this y value is at 0. You multiply it by 10, stays at 0. This y value, which is at -1, multiply it by 10, goes to -10. This y value that's at 0, multiply it by 10, stays at 0. This is y value of 1, multiply it by 10, and try to keep the same scale. That goes up to 10. And then y value of 0, multiplied by 10, 0. So here's our curve after we deal with the reflection and the vertical stretch or the amplitude. The period comes from, again, the normal period, which in radians is 2 pi, divided by this coefficient on theta, which is 1. So the period is 2 pi. The phase shift, which I showed a new way to find the phase shift yesterday. Phase shift is just to take what's inside the trig function, theta plus pi over 4, set it equal to 0, solve it for x, or solve it for theta in this case, which subtract pi over 4 from both sides, which means move everything to the left pi over 4 units. There is no vertical shift because there's no number out here. That's your vertical shift. So there isn't one. So all we have to do is take and graph the phase shift, which means move it to the left pi over 4 units. So 0 radians, 0 degrees, move it to the left pi over 4 units, which is the same as 45 degrees. So now it sits there. Take this low point and move it to the left pi over 4. Move it to the left 45. It is at 90, so when you move it to the left 45, you will end up at pi over 4. Take this point, that is where it crosses the x-axis, move it to the left pi over 4, which again is 45 degrees. So we're at 180 to the left, 45 is at 135, which is the same as 3 pi over 4. This point, that is at the high point, move it to the left 45 degrees, or pi over 4 radians. It's at 270, so move it to the left goes to 225, which is 5 pi over 4. 360, move it to the left, 45, which is 315, which in radians is 7 pi over 4. And final graph in blue is the end result and the final graph. So blue is final. Next example is problem number 6 from worksheet B. It is in degrees. So first of all, cosine curve in degrees. Cosine starts at high point. 1 cycle, 360 degrees, ends at high point. And there's those 5 points that I have stressed since day 1. This is 90, 180, 270. Again, paragraphs, we need to know them. Amplitude comes from that curve right, or that number right there. That is your amplitude. 10, again, same as last one, sorry. It is also in terms of all of our transformation work, it is your vertical stretch. So you take all of your y values, multiply them by 10. It's going to go up to 10. That one stays at 0. This one goes down to negative 10. This one stays at 0 and goes up to 10. So there's the amplitude change. The period in degrees, let's not use green because we already used it, is 360 divided by that coefficient. Again, it is the normal period divided by 3, so 120. The other thing that that 3 does is that it divides your x's by 3. So take all of these important x's and divide them by 3. So this point stays, because its x is 0. Blue point, that's at 90. 90 divided by 3, 30, and I'll try to do this to scale. Take this low point, divide its x value, which is 180, by 3, and it's at 60. Take this x value that's out here at 270, divide it by 3, that goes to 90. And this 360 high point, divide it by 3. 360 divided by 3 is 120 high point. Now what we have, just so we again see something, we said the period is 120. And a reminder, the period is the horizontal length for one full cycle. And there's one full cycle from start to finish. It's 120 degrees, which is what we said our period would be. The phase shift, take what's inside, 3x plus 180, set it equal to 0, solve it for x, and that gives us negative 60. Move 180 to the other side, divide by 3. Which this means, move everything to the left 60 degrees. So, this high point, the start, move it to the left 60. That will come back here to negative 60. Where it first crosses the x-axis, move it to the left 60. It goes to negative 30. This low point that is at 60, move it to the left 60. That goes back to an x value of 0. This point that is at 90, where it crosses the x-axis, move it to the left 60. So 90, move it to the left 60, that goes back to 30. And the ending high point, which the x value is at 120, move it to the left 60. 120 to the left 60 ends up at 60. And then we have what's in black is after the phase shift. Once again, there is no vertical shift because there's no number out there. None. Now, if there was one, I always do the vertical shift last, which just would mean take the black curve and move it up, down, however far you are to move it. I hope this helps doing an example from each worksheet. Again, if you have questions, email me or Schoology message me, and I will get back to you. So in these next 2 days, you should finish worksheet A, which you got on Friday, worksheet B, that was attached with the e-learning stuff yesterday. Have a great afternoon, evening, and have a great day tomorrow.